beams distributed loads. Loading intensities which are constant or which vary linearly are easily handled. Consider this picture. Illustrate the three most common case and resultant of the distributed load in each case. In the part A, we see that the resultant R is represented by the area formed by the intensity omega force per unit of the length. The resultant is omega L equals to area of distributed force. And the length L over which the force is distributed. The resultant passes through the centroid of the area. Centroid of the area of distributed force. The second case also we have R equals to 1 second force and resultant past the centroid of the area of distributed force. Then another case, for part C, the trapezoidal area is broken into rectangular and triangular area. The rectangular deep trapezoidal case example, we have this trapezoidal forces equals to two area. The area 1 L omega 1 omega 2 omega 1 plus and rectangular case omega 2 minus omega 1 with the resultant case R and R1 and R2 here. R1 equals to W1L, this L, and R2 1 second L W1. This is the 2L on 3 and this is L on 2. and the final resultant on beam is 2 force R1 at L second and R2 at 2L.3 second for calculating the support loads, and for the internal load it will be discussed. For the more general case, consider this picture. For the more general case, we must start with a differential increment of force dr as shown also in the picture, W dx. The total load R is then be sum of the differential force with integration W dx from point 1 to point 2. As before, the resultant R is loaded at the centroid of the area under consideration. The x coordinate of this centroid is found by the principle of the moments, which said that R multiplied to x R before calculated here. For the distributed force in this picture, the vertical coordinate of such need not to be found. Once the distributed load have been reduced to their equivalent concentrated loads, the external reaction acts on the beam may be found by the straightforward static analysis of the beam. These forces also have the internal effect, which will be described in the next sections.